All right, by request, we're going to do number 9 out of 3.1. Let me actually write that on there. And let's see, when a vertical beam of light passes through a transparent medium, the rate at which its intensity decreases is proportional to the intensity itself. So I'm just going to go ahead and say the rate at which the intensity changes is proportional to the intensity itself, which will imply, by the way, that di dt is equal to some constant k times I. Let's see, in clear seawater, the intensity 3 feet below the surface is 25% of the initial intensity. So we are given the following initial condition that, let's see, it's actually not an initial condition, actually, it's a condition. So let's see, the intensity 3 feet below is intensity 3 feet below. Remember, T represents the thickness of the medium, not the time, actually. So 3 feet below the intensity is going to be 25% of the initial intensity, which they're calling I sub 0. All right. And let's see. Oh, by the way, this is assuming that the initial intensity is just the intensity at the surface. Okay. And we want, through some computation, we want to get the intensity 15 feet below the surface. Okay, so that shouldn't be too terrible. I'm going to go ahead and work with this differential equation right here. And while we should be able to easily state what the equation looks like, I'm still going to solve it out just to show the mindset behind the scenes. So this is an aside, but in reality, you should kind of already know what the function I is going to be. I'm going to separate variables in that differential equation. So I have 1 over I di is equal to k dt, even though technically speaking, like I said, you should technically know what the function I is. There's only one function that is equivalent to its derivative, or a constant times its derivative, and that's the exponential function. But we're just going to prove that here. Integrate both sides, you'll get the natural log of absolute value of I is equal to kt. Remember, t is thickness. And now I will raise, and there is a plus c here, plus c sub 1. Raise both sides base e, you get the absolute value of I is equal to e kt plus c1, and I'll break that into 2 exponentials, e to the kt, e to the c1, and e to the c1 is just another constant, so I'm going to call that c2, e to the kt. And I'm going to remove that absolute value bar. If I do that, the intensity of the beam of light would be plus or minus that c sub 2 e to the kt, but I'm going to absorb the plus or minus into a brand new constant, c e to the kt. Great. So now we know what our function looks like. Let's go ahead and find out through some of the information they've given us what these c's and k's are. Since I of 0, the intensity at time 0 is I sub naught, well, then I of 0, which is equal to c e to the 0th, which is a c, should equal I naught. So in other words, c is I naught. So I'm going to replace that c right here with I naught. Piece by piece, this implies our function I of t is going to equal I naught, our initial intensity, e to the kt. And then I'm going to use also this extra condition here. Let me highlight it. This guy right here, that when the thickness is 3 feet, the intensity is 25% of I naught. This is finally going to give me this. So again, I'm going to let the thickness be 3 here, so that t I'm going to let be 3, and the output should be 25% of I naught. And of course, doing a division, the I naughts will cancel, and you will get 25% is equal to e to the 3k, and now you can take the natural log of both sides. And then you can divide both sides by 3. So this tells us that the natural log of 0.25 divided by 3 is equal to k. And so now we know our total function is I of t is equal to I naught e to the normally kt, but this is going to be natural log of 0.25 over 3t. That is our function. And I'll highlight that. There we go. Now to go back and answer the question at hand, the question was, what is the intensity of being at 15 feet below the surface? So all I need to do now is plug in 15 for t. I of 15 will equal I naught e to the natural log of 0.25 over 3 times 15. And let me grab a calculator. This is roughly equal to 0.123098 I sub naught, or 0.098% of I sub naught. So it's almost just 1/100th of a percent. I'm sorry, 1/10 of a percent of the original intensity.